Okay, basically this is paper March 2025 paper. Okay. And paper 42 9701 question number 6C onwards. It's related to NMR spectroscopy, or they are saying a student analyzes an aromatic compound X C8H8O3 using NMR spectroscopy. This figure shows the carbon-13 NMR spectrum of a sample of X dissolved in D2O. Okay, and we are getting this much peaks. It's going to be 1, 2, 3, 4, 5, 6, 7, 8. 8 peaks I can see in carbon-13 NMR, because in the next part they are asking how many peaks we would be getting in carbon-13 NMR. So I said 8, isn't it? I said 8. It's very simple. Okay. Or then they have told you about this one, that in a proton NMR spectrum, how many peaks I am getting, and after dissolving the sample in D2O, so I am getting the 4 peaks. So it means that 2 peaks have been disappeared. 2 peaks have been disappeared. Okay, so that's why I'm getting 4. Or now they are saying why the X is dissolved in D2O before obtaining its proton NMR spectrum. Okay, so I can say to remove the peaks, isn't it? Before dissolving in D2O, the peak was 6. After dissolving in D2O, the peak is 4. 2 peaks have been disappeared. 2 peaks have been disappeared, right? So I said to remove the peaks, to remove the signals. Okay, to remove the signals. That's it. Now, they're asking aromatic compound X gives a yellow precipitate when it reacts with alkaline iodine. Use the information in C to suggest a structure for X. C is like that. This is the whole C. Okay, this is whole C. How can I draw the structure after looking at the provided information? So now you can see in this question, they have mentioned that this compound is giving us the positive test for the alkaline aqueous iodine. We know that alkaline aqueous iodine is positive when we have these two, when we have when we have these two groups, isn't it? Methyl ketone and CH3CHOH. Now we have to decide whether I have this one or whether I have this one, right? So it's crystal clear that we are supposed to have these two groups. And interestingly, they have told you that the sample is dissolved in D2O, so the 2 peaks have been disappeared. So means that there should be an alcohol. I'm talking about OH, isn't it? They're talking about OH, so it must have the two OH groups. It must have the two OH groups. Why? Because 2 peaks have been disappeared. 2 peaks have been disappeared. So means that I must have two OH groups. Okay. So let me write it down to make it easier. Let me write it down to make it easier. I must have two OH groups. You know why? Because the 2 peaks are disappeared. Okay. Okay, then uh, this compound that we are going to draw must have 8 carbon environments and 6 proton environments. Keeping in mind, okay, it would help you a lot. Okay, so now you can see on the x-axis. So the peak that we can see over there. Let me tell you about that. See this. This is the carbon 13 NMR ranges. Okay, so okay, so what was the range? It's around 205, around 205, right? So If you can see in the table, 205 is lying between this, right? 190 to 220. So 205 is in between this. This peak shows that you have carbonyl. This peak shows that you have carbonyl, means you have C double bond O. So it is confirmed. We were so confused that what is the group present? Is that CH3 CHOH or is that CH3 C double bond O? Because the compound is giving us the positive test for iodoform. So now this is confirmed that we are having this one, not this one, isn't it? It's crystal clear from the given table, given data. Okay. Now, um, then we have, you know, uh, the peak that is at the peak that is at yeah, okay. So now we have to think about that. They have told us that aromatic compound we have. Aromatic means this is called aromatic ring. This is going to be arene. It's a benzene ring. Okay. And and I must write. I must write anywhere CH3 C double bond O. This group is giving us the positive test for this alkaline aqueous iodine, right? Okay, understood. So now I must have the two OH groups. So where I should attach these two OH groups? Okay, so let's say I'm attaching OH and OH. Let's say random. Now I'm asking how many carbon environments I have. So you will say, sir, one, two, three. One, two, three. Okay, it's going to be four. It's going to be five, 6, 7, 8, isn't it? Is that correct? Is that correct? All environments I have, because in the question they have told us that it has total 8 chemical environments. So I'm getting total 8 environments. That's it. Let's suppose if some of you are asking, sir, do we attach, can we attach the OH groups like that? Yes, you can attach if you are getting the same peaks. Let's say, count it. One, two, three, four, five, six, seven, eight, isn't it? But let me tell you one thing. You cannot do like that. Let me tell you why. One, two, three, they are the same environments. Four, okay, they are the same environments. And then four, then five, then six. So it is having the six environments. No, we must have 8 peaks. So it's going to be better. It's going to be better because when I attach OH over there and there, so I was getting 8 environments. Still, when I attach OH at these positions, still I'm getting 8 environments. So that's correct. Okay, right. That's okay. So this is the reason after looking at properly the data, what type of data is given to you, and they are saying they are going to give you the positive alkaline aqueous iodine, and they have told you about that, like when we dissolve the sample in D2O, so the 2 peaks have been disappeared, so we get to know that this should be an alcohol OH group. Okay, so then we can draw the structure. And since in the formula they have given you 3 oxygen atoms we must have, 3 oxygen atoms we must have, right? So after getting an idea about that, so we got to know about that. So it's very simple. But Before going to do NMR questions, you must know about the total chemical environments. How do we find out the environments and how do we look at the given data table so that we can decide what the group is present, what the functional group is present? Okay.